All right, our next learning target today is learning target 2 for unit 3 on 8.1. And the learning target is make a model to show how atoms are different from one another based on their structure and that they have similar patterns of the number of protons, neutrons, and electrons in it. So let's go to a dynamic periodic table. If I click on, or I highlight this periodic table, this will actually tell me all about hydrogen. This is like really cool that they have different properties. But hydrogen, as we hover over it, has one proton. Well, we'll talk about this. It has a 1, an H, and then it says hydrogen, and then it says this number right here. And then it's different for helium. And helium's 2, He, helium 4.0, and lithium is 3, Li, lithium 6.94. So what does this all mean? So we're going to kind of talk about oxygen for a minute. The first number up at the top is called the atomic number, and I'll just highlight this and edit this one so we can see it. So the atomic number is the number that they give right here. This number 8 is called the atomic number, and it is always the proton number. So the proton number really determines the atom that we're looking at. So if you have like 8 protons in it, it will always be oxygen every single time. If you have one proton every single time, it will be hydrogen. If you have 3, every single time it will be lithium. The O right there is called the symbol. Oxygen is the name, and this 15.99, this is kind of interesting. This is called the atomic mass. It is actually an average of most of the elements' protons. Actually, I'm going to just do this. It's the average of protons plus neutrons. Now that will go into more detail when you get into high school chemistry, but the best way to do it is to round up wherever it goes to. So 15.99 rounded up is 16, and we know that it has 8 protons. So if it has 8 protons, how many neutrons is it going to have? Well, we know that 16 minus 8 would be 8 neutrons. So this atomic mass has 8, or this element mostly has 8 protons, 8 neutrons. Sometimes it might have a few oxygen atoms with 7 neutrons, but we'll talk about that and show that in a second. So let's go into this PhET model, and we're going to see if we can complete our 3.4 lesson to help us understand. So notice right here is a periodic table. If I pull in a neutron, nothing happens. If I pull in an electron, nothing, like you can see them in their spots, but you can't see an element made. So once I pull in a proton, boom, it becomes hydrogen. So we're going to look at it stable. We're looking for stable neutral atoms. The interesting thing about hydrogen, based on this dynamic periodic table, is you can see that hydrogen is 1.008 is its mass. So that means most of the time hydrogen is going to have 1 proton and 1 electron. And sometimes, every now and again, it has 1 neutron. For our class, if you follow the pattern of 1 proton, 1 neutron, and 1 electron for element hydrogen, which is number 1, then we will support you and not take away any points for those. So if I add a proton, it becomes helium. If I add a neutron, it becomes still helium. And if I add an electron, it's still helium. And it's a neutral atom, and it's stable. So let's go back to our assignment. So we learned that hydrogen has 1 proton. It can have 0 to 1 neutrons. It has 1 electron, and then there's this thing of an outer electron. The outer electron is this outside shell. So let me pull these back out just one more time. This outer electron shell right here, the most outer electron is 1. So we have 1 outer electron. When we come back and we build up our helium, now we have 2 outer electrons, 2 protons, 2 neutrons, and it's stable. So we have 2 protons, 2 protons, 2 neutrons, 2 electrons, and in its outer shell, we have 2 electrons. Let's go to lithium. So if we add in a proton, we're at number 3, lithium. It's shaking because it's unstable. So let's add a neutron. Now it's stable. and if we add an electron, then it becomes a neutral atom. But I can't put the electron on that first shell. And the reason for that is because the first shell can only have 2 electrons. So over here, I'm going to put 3 protons, 3 neutrons, 3 electrons, and 1 outer electron. Because if you look right here, this shell has the outer electron. So far about atomic models that we need to understand is we need to understand that the periodic table has a certain pattern that it's going to go through. It is going to increase by 1 proton, 1 neutron, and 1 electron going across the periodic table. The other thing that we need to know is that that protons and neutrons go in the middle nucleus, and that we have electrons are on the outside shells. The first electron shell can hold up to 2 electrons. And now we're working on the second electron shell. So let's see how much that second electron shell can hold. So going back to here, if we do beryllium, beryllium's kind of weird. Beryllium needs 1 more extra neutron and then an electron. You don't have to stress. If you put 4 neutrons on beryllium, no big deal. So this is a stable neutral atom. It has 4 protons. In this case, it has 5 neutrons, but you could say 4 and 4 electrons. So if you go here, we go 4 to 5 neutrons. Either one would be okay. 4 electrons. And then how many outer electrons? Has 2 outer electrons. So we're going to put a 2 there. Okay, for boron, if I add a proton, it becomes boron. It's stable because it has the correct number of neutrons already, 5, and now it has 5 electrons. 2 electrons are on this first shell, 3 electrons are on this next shell. So we have boron's number 5, 5 protons, 5 neutrons, 5 electrons, 3 outer electrons. And if you actually look at this periodic table, it'll show you, like beryllium right here, it'll show you 2 electrons are on the first shell, 2 electrons on the second shell. Here's boron, and boron shows 2 electrons on that first shell, 3 electrons on the second shell. So this dynamic periodic table is a good resource. Let's go on to carbon. Has 6 protons, 6 neutrons, 6 electrons. So it has 6 protons, 6 neutrons, 6 electrons, and 4 outer electrons. If we go into nitrogen, nitrogen has 7 protons, 7 neutrons, and 7 electrons, 2 of which are in the first shell, 5 are on the next shell. So 7, 7, 7, and 5. I think you know the pattern. Oxygen has 8 protons, 8 neutrons, 8 electrons. 2 are in the first shell, 6 on the next. So we would type in 8 protons, 8 neutrons, 8 electrons, and 6 outer electrons. If we do fluorine, fluorine actually is stable with 10 neutrons. It's kind of weird, but it still has 7 electrons to be considered a neutral atom. And a good way to think about neutral atoms is that protons are positive, electrons are negative, neutrons are kind of neutral. So it becomes neutral when you have the even number of protons and electrons. If I take out a proton, it becomes a negative ion, and it becomes a different element. If I take out an electron, that becomes a positive ion. So let's write in a couple things from those notes. 9 protons, 9 neutrons, 9 electrons, 7 outer electrons, and we still don't know how many the second electron shell can fit, but it's probably good to know protons are positive, electrons are negative, even number of protons and neutrons is a neutral atom. And the other thing is neutrons have no charge, or you can say they're neutral. All right, we're almost done with our pattern. So let's do our last one. Here is neon. It's stable because there's 10 neutrons there, and I can add 10 electrons there. So now on our last one, we have neon is 10 protons, 10 neutrons, 10 electrons, and 8 outer electrons. So our second shell can hold up to 8 electrons. So what happens next? We ran out of this row. Well, what happens next is we can have a third electron shell, and it too can hold up to 8 electrons. So if you go into the dynamic periodic table with sodium here, maybe it'll show us a picture of sodium's model. We can hope. Oh, it doesn't. It has too much fancy stuff going on. So if I look at sodium right here, sodium actually has a 2, an 8, and a 1. So it has 2 on its first shell, 8 on its second shell, and 1 on its third shell. So if I type in a sodium atom model here, you can see that it will have 11 protons, 11 neutrons, 2 electrons here. We'll make it big. 2 electrons in the first shell, 8 electrons in the second shell, and then it opens up and has 1 more electron on the third shell. So we have 11 protons. I think it showed about 12 neutrons, 11 to 12 neutrons, 11 electrons, and 1 outer electron. So if we do the same thing and type in a magnesium atom model, magnesium atom models are going to look very much the same. It has 12 neutrons in the middle, 12 protons in the middle, 2 on the first shell, 8 on the second shell, 2 on the third shell. So it has the outermost electrons are 2. So 12, 12, 12, and 2. And you could keep going on the pattern, and you would see that it would follow the pattern of increasing by 1 proton and 1 neutron every time, and it would increase in 1 more outer electron as it fills up the next electron. So that you might notice that even there is a definite pattern going across, but there is also a pattern going down. See if you can figure out what is the pattern going down. Well, this one has 1 outer electron, this one has 1 outer electron, and this one has 1 outer electron. So if I were to insert a row above this, this one would have 1 outer electron. And because this row is 1 electron away, so we'll go back to the sodium model. Because sodium is 1 electron away from being a complete shell, it's going to do something really unique. It will try to get rid of this electron. There is a great video on that I will refer to at the end of this show, but 1 outer electron means it will try to get rid of that 1 outer electron, and it will bond once. Okay, so our next one, let's change the color to this so we can see it. Okay. Oh, maybe I should make it clear. Clear is better than white, transparent. Okay, so on this row for beryllium, beryllium has 2 outer electrons in this row. So if it has 2 outer electrons, it also makes 2 bonds. This row here makes 3 outer electrons, and it would make 3 bonds. This row here has 4 outer electrons, and it would make 4 bonds. This row here has 5 outer electrons. We'll talk about the bonds in a second. This one has 6 outer electrons. And this one has 7, and we didn't finish it here, with 17 protons, 17 neutrons, and 17 electrons. And you have 7 outer electrons there. So this one would have, not 5, sorry, 7 outer electrons. This one, argon, is 18. It has 18 neutrons, 18 electrons, and 8 outer electrons. So one of our other key traits is that the rows have, or sorry, not the rows, the columns have the same number of outer electrons, and this determines the number of bonds. So going back to what happens with nitrogen. Well, Or actually, let's go down one more, the one below it. Let's talk about phosphorus for a second. A phosphorus